What is a pluton? These are the plutonic rock bodies, that means the igneous rock that has cooled down at a great depth with coarse crystals. What is a batholith? These are the plutons with more than 40 mile square areal extent. These are the greatest body of igneous rocks. The base of the batholith has been questioned. Some earlier literature has said the batholith has unknown depth, but geophysical studies have shown at many places their depth can be 7 to 8 kilometer. Here is an example of batholith of huge vertical extent, and it has got some digitations of pegmatite, and here in these places block faulting like situation is visible. What is a lava dome? These are formed by highly viscous lava that form bulging or dome shaped bodies. So, this is an example of a lava dome. It is a hot molten lava and a domal geometry is produced. Domal surface may be made up of fragmented or lava. This surface can be consisting of the lava. Coming to a smaller scale, some terms are to be remembered, and these are important in stratigraphy of the volcanic rocks. Xenolith, these are the rock fragments plucked off the country rock during magmatic intrusion. Say this is a country rock, and within that a magmatic body is getting intruded, and then this geometry is produced. Within the magmatic body, after emplacement, we can find out small pieces of the country rock. In the principles of included fragment, I have already said that if this is the situation, then the country rock is, or the rock which is coming as an inclusion within the xenolith, is older in age than the magmatic material. So, once I say younger in age or older in age, I mean relative age. Otolith, what is that? These are the fragments of older intrusions inside later intrusions. Suppose an intrusion has happened I1, and then another intrusion I2 has happened inside I1. Now, it is possible that the fragments of older intrusion, this I1 is older, I2 is younger, we can find I1 as fragments. In that case, we call this I1 as fragments as the otoliths. A general term enclave has been used when we are not sure whether the intruded fragment is from the host rock. Say this is the host rock, and within that I have got an intruded fragment H. I do not know whether H source is capital H or whether it has come from some other place and got deposited. So, in that case, in volcanic studies enclave word is used. In this case, H is an enclave. We are going to see the pyroclastic deposits in some detail. What is a bomb? It is a clot of magma that were partly or entirely plastic when erupted. Not just the fine ash particles or gases are erupted, sometimes clots of magma are erupted. So, this is a volcano from where a clot of magma is erupted, and once it falls on the ground, it actually flattens due to its own weight or due to, and also due to its impact. That is what is said, flattened after landing. They have more than 64 millimeter diameter. Here is an example of a bomb. What is a block? These are the erupted solid fragments. When magmatism is happening, not just the clot of magma, the molten material that is thrown out, sometimes the hard rock is also thrown out. This hard rock is known as the block. What is lapilli? These are the solid or liquid materials within 4 to 32 millimeter in size. The thrown out materials from the magma can have lapilli, which can be solid or liquid materials with 4 to 32 millimeter in size. In some book you will find instead of 4 to 32 millimeter, 2 to 64 millimeter, and we can take this one as the better definition. Pellets here, these are finely spun glass threads. These are the lapillis, these are the bombs, and this is the pellets here. There are many other terms such as accretionary lapilli. These are these spheroidal concentrically layered pellets formed by accretion of ash and dust by condensed moisture in eruption clouds. Ash is an incoherent ejecta, fine particles, their mean diameter is less than 2 millimeter. Pumice and scoria, these are the ejecta of melt that have porosities of 30 to 80%. Pumice has intermediate to siliceous composition and scoria is andesitic to basalt. So, the difference in definition of pumice and scoria lies on the rock type or the chemical composition. In case of scoria, it has to be andesitic or basaltic, whereas for pumice it has to be intermediate to siliceous. Strix or phaeum, strix are the deformed pumice, tuff or tuff are the consolidated volcanic ash. Volcanic ash is very fine grained, but they can consolidate with time. Welded tuff, this is the same as what I was saying when hot eruption happens. Sometimes pyroclastic deposits fuse by solid state diffusion. Ignimbrites, these are the welded ash flow tuffs. Tephra, these are the all kinds of ejected materials from volcanoes. So, tephra is a most general term, and within tephra will be all these terms: bombs, blocks, lapilli, pellets here, etc. Diatreme is a pipe-like body of breccia composed of fragments of neighboring country rocks. This I have already described. If we plot in a ternary diagram the glass component, the crystals and the rock fragments from a volcanic eruption, then we can define the crystal tuff, the vitric tuff and the lithic tuff. This line is 50% of glass and 50% of rock fragments. Let us look at photomicrograph of ash. This is the one, a vitric tuff under microscope, which is here, and again another example of vitric tuff, which is figure C. Within vitric tuff, the pumice has been identified, that means the individual pieces have been identified. If you make a ternary plot of blocks and bombs at one apex, lapilli as a second apex and ash as the third apex, different rock types can be identified, such as pyroclastic breccia, tuff, lapilli tuff and lapilli stone. We have to be aware of pyroclastic fall. These are the deposits that form from pyroclastic materials falling directly out of the sky. They mantle topography with a uniform thickness over large area, show systematic decrease in thickness and grain size away from the source. There are two end members of the pyroclastic falls. One is a strombolian eruption, another is a Plinian eruption, and these are the figures of strombolian deposit and the Plinian deposit. The strombolian deposits tend to form cone geometry. As you see, eruption from here to here has happened, whereas in case of Plinian deposit there were more fine grained ash particles and it has moved more distance than that of the strombolian deposit. You can ask what decides the flow in this direction. Suppose there is a volcano and eruption has happened. Now, depending on the prevailing wind direction, the deposits, the fine ash particles will be deposited. The wind direction is important. So, in these two diagrams, which means the wind direction was left towards right hand side. If they were right towards left, this would have become like that. Dispersal axis means in which average direction the ash particles have moved. In case of a strombolian eruption, this one eruption column is low, 1 to 3 kilometer. Fragments accumulate around the vent and forming the cone. Stromboli volcano is an example, whereas in the Plinian eruption, the eruption column is high and pumice and ash can spread over long distance. Since the eruption column is high, so there is a good chance that it will be affected by a steady flow of air, which might be missing in case of the strombolian eruption. If we compare which one out of these two, strombolian eruption and Plinian eruption, is spread more laterally, the answer is it is Plinian eruption. A more regional stratigraphic correlation is possible with Plinian eruption. in comparison to the Strombolian eruption. The extrusion of the lava dome is shown here. The lava dome becomes unstable and top sides off. It can be possible that there has been a discordant relationship and an intrusion, but then one piece of that actually slides down. We can call it one kind of landslide. And after a long geological time, it is possible to have decompression and explosions and new lava extrusion. What is the meaning of the term pyroclastic flow deposits? By avalanche of pyroclastic fragments that fill up the depressions, they do not mantle the topography. They are similar to the debris flow. They are poorly sorted from ash up to boulder size and can form when a growing lava dome collapses. Typically, it is monolithogenic. And what is a ferratomagnetic or hydrovolcanic eruption? These are the explosion through a vent where groundwater has ready access. So, what happens in presence of groundwater? Rapid vaporization takes place and thermal explosion happens and the fragments of materials are thrown apart. And it gives rise to glassy ash or hyaloclastite, which are sand-sized particles. Let us see the volcanic stratigraphy. Establishing stratigraphy from the volcanic rocks, volcanic deposits is complicated. What are the reasons? The lava flow leads to the rock formation, the igneous rock formation, but this happens at a faster rate in comparison to aeolian deposition and the fluvial deposits. The rocks are friable in nature. Volcanic deposits can be layered and these layers can erode very easily. So, we may not get a complete succession. In fact, part of it might be already eroded. This makes the correlation difficult. The topography is unstable. There is drastic change in volcanic facies as one moves horizontally. A drastic change in facies is a problem also in case of glacial stratigraphy. As I referred in point 2, point 5 says nearly the same thing, that erosion after short primary deposition is common, and in that case we do not get the complete record of volcanic rocks. The formal units are missing. Nevertheless, I will present you how we work with the volcanic stratigraphy. Explosive eruption with widely dispersed tephra can produce good stratigraphic marker. Suppose an explosive eruption has thrown the fine particles up in the atmosphere, then it gets deposited and geologically very short span of time will be indicated from these stratigraphic markers. Can we use the Pavlov structure and the ropey structure in correlating the lava flow? The answer is no. The reason is the same lava flow. At one place can leave a ropey structure and at another place it can leave Pavlov structures, and therefore such structures are not used in volcanic stratigraphy. There are two terms important in volcanic stratigraphy: synthem and supersynthem. What is a synthem? It is a volcanic phase and unconformity bound stratigraphy units. A supersynthem consists of several synthems. While talking lithostratigraphy, I mentioned that groups and supergroups can be unconformity bounded. Similar term we are finding in volcanic stratigraphy is synthem. Also, somewhere in lithostratigraphy I mentioned that the unconformity demarcating the upper and lower boundary of group or supergroup can indicate dissimilar amount of time gap. That problem can also persist over here. Unconformity bound stratigraphic units defining the synthem. In this case also there is no guarantee that the unconformity indicates equal amount of time gap, and this can again lead to a problem in correlation. Let us say there is a volcanic deposit A and there is a volcanic deposit B. In between an unconformity is established and this unconformity is marking A to B million year time gap, and elsewhere we have found A and B with unconformity, the same unconformity, but the problem here is the time gap can be A dash to B dash million year. These unconformities develop between two eruptions, but having said this, it is still not very easy to use these unconformities. The reason is there are minor unconformities that develop between two pulses of the same eruption. The eruption is the same, but within that there can be two pulses, and between these two pulses unconformities can also develop, because there can be a smaller time gap. So, in smaller time gap minor unconformity can develop, and between two eruptions a major time gap, and there significant unconformities can develop. Between two volcanic flow layers A and B, one can find an unconformity, and this unconformity can be characterized by paleosols or bowl beds. Let us see how the red bowls look like. I am taking an example from the Kharghar hill. B1 stands for a basalt unit and B2 stands for a basalt unit. In between this red colored unit is called the red bowl. A zoom is shown here, and the different joint planes within the bowl unit can be seen. There are a few irregular cracks. Now, for some purpose this bowl bed has been divided into two parts, the P1 and the P2 portion, and further divisions can be made if required, such as C, D, E, F, G and H. Single piece of the red bowl can be comparable with brick. It is only a superficial comparison, looks like so, not just in Mumbai. Deccan trap exposures in the Pune city at several places has got thick red bowl units. Here is an example how in vertical section the layers of lava flow can look like. One can find out paleosol or paleosoil. This means a gap in lava flow. Where the lava flows, they will be at the bottom of this paleosoil and at the top of this layer. Then again another paleosoil layer has been found. This will indicate again a time gap. And the other units are ignimbrite, ash, ignimbrite once again, and pumice fallout. This is a stratigraphic scheme of Mount Etna volcanic district. We need not remember all the names, only I want to emphasize that the synthems have been defined. The two synthems have been grouped as a super synthem. Same thing, top of this two synthems have been defined and they have been grouped into a super synthem. This top super synthem has been linked with a stratovolcano. Once we look into the synthem individually, we find that there are formation, which is a lithostratigraphic term, has been used. So, these are the formation. Looking closely, one also finds the members defined in between the formation. So, here are the formation, these are the formation names. Just recollecting the lithostratigraphic scheme: formation, member, bed, group and supergroup. In this case of Mount Etna district, formation and member, these two terms have been picked up from lithostratigraphy. And the term synthem and super synthem have been picked up from volcanic stratigraphy. While studying the volcanic stratigraphy, let us look at the Indian context. In western India, we have the exposures of Deccan trap. mostly basalt, came into existence at the KT boundary, the Cretaceous Tertiary boundary, or the end of Mesozoic. Mainly that is the Indian mainland. This is Mumbai, from where I am recording my lecture. The green color represents the Deccan Trap exposure. This is a main central Deccan sub-province. Then the Malwa province, another place of exposure of the Deccan Trap rocks, and the Mandla sub-province. And the fourth one is found in the Saurashtra Kutch sub-province. This is the state of Gujarat, where this portion known as the Saurashtra region. In the old literature, it has been called as the Kathiawar. This portion of Gujarat is the Kutch region, and here we are also getting much less aerial extent of the Deccan Trap rocks. What is the meaning of the word trap? Trap comes from the word trappa, which means stairs. The Deccan Trap rocks at many places, but not at all places, has got this step kind geometry, step like topography. And in Indian stratigraphy, three terms can be seen: infratrappean, intertrappean, and intratrappean. Let us try to understand. Infra means we are talking about a unit which is below the traps. That is what is said, lying below the trap. Example is the Lametta formation, which is exposed well in Jabalpur in Madhya Pradesh. Madhya Pradesh is a state in the central India. Here is Jabalpur. Here one can find out the infratrappean, the Lametta formation, where carbonate is a dominant lithology. So, if I draw very ideally as a trap material, then what lies below is the infratrappean. Now, let us take the term intertrappean. The word inter means in between two units. So, here in between two lava flows, for example, from Rajamundry in Andhra Pradesh, intertrappean units are found. Suppose this is a lava flow 1, and over that lies lava flow 2, then this in between place is known as the intertrappean. And this is a trap material just like that. Now, let us look at the term intratrappean. Intra means inside a single flow. That is what is said. Inside a single lava flow, there can be new pulses of lava flow, such as sill. Sill is a concordant igneous body, that means which lies parallel to the existing layers. And the example comes from Anjar in Gujarat and Rajamundry from Andhra Pradesh. Within this trap material, suppose a late phase concordant magmatic intrusion has happened, then these are known as the sills, and since it is occurring inside a single trap, therefore, it has been called as an intratrappean. Let us look at an intertrappean unit. The example comes from a place in central India, Sagar. Two flow layers can be seen. Top one has been called as flow 6, the bottom one has been called as flow 5. In between, intertrappean. In terms of the schematic diagram, this green layer indicates the different flow layers, and between flow 4 and flow 5, intertrappean 1 has been worked out. Between flow 5 and flow X, intertrappean 2 has been worked out, and here intertrappean 2 has been given as an example. Just to tally between this map and the one that I showed here for the international viewers, this is Gujarat and specifically this portion Saurashtra, which was also earlier known as Kathiawar. This is the Kutch region within which Deccan volcanic rocks are exposed with much less aerial extent. This is India's west coast and this place is the Arabian Sea. We want to see two more terms, post-Trappean and subtrappean. Rocks that lie above the trap are known as the post-Trappean. That means they deposited or formed or they came into existence after the Deccan trap rock came into the picture. What lies below the trap material is called as the subtrappean material. In case of Deccan trap in Indian stratigraphy, the subtrappean sediments are of Mesozoic age. These sediments are of Mesozoic age. These subtrappean rocks have been studied for hydrocarbon prospect. In this context, also note the prefix sub in subbasalt, such as in subbasalt imaging in general, which means subsurface, and in the same sense we say subsurface geophysics. When we say subbasalt imaging, that means we are looking at the subtrappean. The term facies is very common when we are studying the sedimentary rocks. However, the term rarely has also been used to define igneous facies, a certain association of rocks and their physical characters through which paleo environment or some specific conclusions might be made. I am going to give an example from the Yerwada Katraj Ghat section from Deccan Trap, which is near Pune in the state Maharashtra in the country India, where recently Sharma and others 2025 research paper defined igneous facies. These are the field photographs of the different appearances of the igneous rocks, here mostly basalts. Total 9 facies have been defined here. When we have an association of spheroidal weathering and columnar joints, the facies name has been given sheet pahoe. Here on the surface ropey appearance of the basalt has been seen. Here are the descriptions. A new term in my lecture is spheroidal weathering. What it is? When we find within the rock this kind of concentric appearance, and in detail we find that these are basically the joint planes, most likely that the rock has undergone spheroidal weathering. Amongst the igneous rocks, basalt is most common, but never try to identify a rock to be basalt based on the spheroidal weathering presence. For example, spheroidal weathering can also be found in granite and other igneous rocks. Spheroidal weathering can also be found in sedimentary rocks even, such as sandstone. Now come to the second one, Hammocky Pahoe facies type. Here on the plan view one can make out the Pahoe geometry. The third is the indurated red bowls. Red bowls I have already defined, and here is the appearance and here is the sketch. Red bowl with lava ball, fourth facies. This is the example of a lava ball and here is the sketch. In this Yerwada Katraj Ghat section, different kinds of red bowls can be identified. For example, facies 5, onion skin weathering in red bowl and rubble red bowl. These are the distinct appearances based on which the rock can be grouped. Basaltic dike can be found. Here is the dike outcrop. Then we can find vesicular or amygdular basalts as the 8th variety of facies, and then massive or jointed basalt, the 9th variety. So, in this way igneous facies can be defined. In fact, in this work, after defining the igneous facies, they added the geophysical studies to describe the stratigraphy of the Deccan trap in a particular region.